through this, and we had our friends try to explain the steps. Okay? I try to explain the steps of finding the parameter of such complex shapes. Starting with just the semicircle and the quarter circle, basically we have to find part of the circle which is termed as arc. So if it's a semicircle, the arc, the length of the arc is half the circumference of the circle. To find the perimeter of the semicircle, I'm using the arc plus the straight line across called the diameter. So there are two steps to it. And for the quarter circle, we find part of the circle called the arc. In this case, the arc is the quarter circle. So the arc for the quarter circle, I use a quarter times the circumference. Then I do the next step using the arc plus the radius and the radius, not forgetting the units. So that's pretty much how this works out. Then we go on to the complex shapes. Let's go through this together, starting with the questions on this page. Adrian, let's go. Here says, the radius of a circle is 7 centimeters. Find the perimeter of the quarter circle. Take pi as 22/7. For this question on page 141. What is pi here? What is pi here?
22/7.
Thank you. So do I press pi on the calculator, 3.14 or 22/7?
22/7.
Thank you. So that's the first one. We need to pay attention to pi. Next, let's carry on to answer the question. Radius is 7, perimeter of the quarter circle. So we are looking at the perimeter of the quarter circle. What are the parts of the perimeter? For the quarter circle's perimeter, what are the parts that makes up the perimeter? First, I have this one. This curve is called the arc. If I want to find the arc, I have to use
1/4
multiply by
pi d,
which is
22.
what is pi d? Pi d is diameter. What is pi d? The formula pi d stands for 1/4 times pi d. What is 1/4? It stands for a quarter of the circle. The arc is a quarter of a circle. Times pi d. What does pi d stands for? It is the formula for circumference of the circle. In this case, they didn't use pi d. What did they use instead? Tyson, you want to hold the mic and answer, or you want to pass it on? In this case, you can see the next step of the working. It didn't continue to use pi d. Instead, it used 2 pi r. Why? 2 pi r is also the formula for what is 2 pi r? What is 2 pi r? It's the formula for also for the circumference of the circle. So by now we should know clearly that there are two formulas that we must memorize for the circumference of a circle. In this case, there are two possible formulas, either pi times d or 2 times pi times r. In this question, they use 2 times pi times r instead of pi d. Why?
Hi.
Sorry?
Radius.
Because the question provides not the diameter, but the radius. That's why you notice that the question continues with 1/4 times 2 times 22/7, which is pi, times the radius 7. The red markings here show how the simplifying is done. Because of the simplifying, it is quick to get 11 centimeter. If you do not know how to simplify, what did I tell you to do? Multiply the numerators, then multiply the denominator, put them all together. But the best thing by now is everybody know how to simplify. Okay? Just work through it step by step. Finally, at the last step, what is happening here? Perimeter of the quarter circle. What is this step now? Summer? What is this step?
Radius.
What is this step here about?
Find the perimeter.
So, how?
All together.
Plus what together?
The radius
Plus radius
and the radius
and
the length of the arc.
length of the arc. So, you have 11 centimeter plus the two straight lines 7 and 7. Then you get the perimeter of the quarter circle. Okay, is everybody clear with that? Let's move on. I think we can do a bit faster in the next question. Come, Aiden. In this question, the question says the figure shows 3/4 of a circle. Find the perimeter of the figure. The figure is... What is the figure again?
3/4 of a circle.
The figure is a 3/4 of a circle. Very good. It says take pi is 22/7. Aiden, what's pi here again?
22/7.
Thank you. I must take pi as 22/7, not the pi in the calculator, not 3.14. Okay, let's continue to ask Aiden the first step. What's the first step about?
The length of the arc
Okay, and then?
times the circumference.
What is the first step about? It says the length of the arc. So are you telling me that this equation here is for finding the length of the arc?
Yes.
Yes. So what is 3/4? Why must I 3/4? Because the figure is 3/4 of a circle. What is 2 pi r?
Circumference
Of the circle. So 3/4 of the circumference of the circle will give you the length of the arc. Does that make sense to everyone? The next step, 3/4 times 2 times pi times radius 14. Does this make sense to everyone? Now I work out by simplifying, I get 66. Now, the last step, Aiden, what's happening here?
The length of
Okay, Janisha, you can say it.
the length of the arc plus the radius
Thank you. The length of the arc plus the radius plus the radius. Everybody clear about it? Let's go through one more example. This one. The figure here is made up of a semicircle. Now, these two shapes are a bit different. One is a semicircle, one is a quarter circle. They are put together to form a figure. They are put together to form a figure. Find the perimeter of the figure. So first and foremost, we got to be clear, what does it mean by the perimeter of the figure? I can help myself by, number one, put my finger on a certain start point and run my finger through around the figure. That's what the perimeter is about. I run my finger around the outline of the shape. That's what perimeter is about. Now, what is happening here? I have the arc here, and then I have an arc here. And then I have straight lines here, and then straight lines here. Oh, there's a straight line here. Why am I not highlighting this particular line?
Because they are connected together.
Wait, the mic is there, you can say. Why am I not highlighting it? Yes, Hongwei and Keshin says this line is dotted because it shows how these two shapes are connected to each other. But why am I not highlighting it? Why am I not coloring it? It's a straight line, right? I colored the straight line here orange, I colored the straight line here orange. Why am I not coloring this line? Summer, you should answer. Why am I not highlighting this line? I went through this last week during media class. Why am I not highlighting this dotted line here, which Kershit and Hongwei rightfully says it is dotted because it shows how these two shapes join together to make the figure. But I am not highlighting this dotted line. Like I highlighted the straight lines here orange, I highlighted the green arcs here, but I didn't highlight this line. Why? Who thinks you have the answer? Please stand up. Or maybe I should change my question. Who don't think you know the answer to the question? Please stand up. Why did I not highlight this dotted line here? Okay, Kashid, you are seated. You want to suggest?
Because it's not a part of the perimeter.
Thank you, Kashid. You are perfectly right. Is that what you wanted to say, Kashid? Yes. What did I tell you to do first of all when you read this question? Thank you, Ryan. Put your finger here and trace around the shape, the outline of the shape. What do you notice? Did my finger touch the dotted line? No. It asks for perimeter of the figure. The figure means the outline of the shape. Do you see me touch the dotted line at all? Can you understand why I did not highlight that dotted line now? Because it's inside the figure, it's not on the outline, it's not part of the perimeter. Can you understand? Sandra, can you explain it now? Why did I not highlight the dotted line? Thank you. Everybody, please sit down. Now that is very important. What is little robot saying? Little robot tells you, look, 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 you could rearrange the shapes. And then in the end, yeah, you're getting 3/4 of the circumference of the circle as one step. The robot didn't find this quarter circle arc, didn't find this semicircle quarter arc, this semicircle arc. He went straight to finding 3/4 of the circumference of the circle. Can you see why? He combined this arc, shifted it, slide it up, and can you see where's the 3/4? Yes? So the first step, 3/4 times 2 pi r, shows these two arcs combined by simply, like how little robot did, sliding it up. Or you can just think of it this way. I have a quarter of a circle here, and then a half of a circle here. A quarter and a half makes 3/4. With the calculation, it's 12 pi. And then it asks for the perimeter. I use the 12 pi plus the orange straight lines. How many times 8 was added? 2. Only 2. Here and here. Now can you really understand why I did not highlight the line inside? It's very, very important. Okay? Right, now you try. There are another 2 questions here. These 2 questions are a little bit more challenging. But let's take a look at this one. This is actually not that hard. This is the shape that I asked you to trace just now. Can you see the steps and understand the steps here? The figure is made up of 3 identical semicircles and a large semicircle. And I ask you to find the perimeter of the shaded figure. First, trace it with your finger. That's the reason why I asked you to try to copy the figure just now. To take note of what you are actually having in your head as you visualize the shape. Can you see where this green arc, where are the working steps for the green arc here? The semicircle. Is it this one here or this one here? Here? Or here? Here. Yes? The big circle. The half the circumference of the big circle. Do you see that the diameter for the large semicircle, it wasn't really directly mentioned to you. You have to find out the diameter of the large circle by adding all this up. Now, I'm highlighting it in pink only because I want you to see the diameter. But should I add these measurements into the perimeter? Again, no. I should be only adding all the green color arcs here, not the pink line. But the pink line provides the measurements for the large semicircle, as well as the diameters for the small semicircles. Can you see the total number of steps? 1, 2, 3, 4, 5. So how many marks do you think this question is? 5 marks. 4 to 5 marks. But look at it. It is a bit difficult, but do you think it's achievable? Yes, very much achievable. But the only reason, I have to say this again, the only reason why some of you are not achieving this, number 1, you don't remember the formula. Which, I tell you, is remembering a formula a possibility to fix? Yes. Practice. Revise. It's a formula. It's like a times table. You've got to remember it. The second reason why some of us cannot deal with this question, you're not patient enough. The truth is, dear 6 perseverance, this is the question that I feel strongly that our class can manage. Because is this a bit complicated? Yes, it's a bit hard. But look at it again. Look at the steps. Do you think these are steps that you can understand and can manage? Yes, you can. Okay? Because it hasn't got to the even more complicated ones yet, where you have like hidden shapes in hidden shapes. That one even I feel challenged by it. Okay, now your turn. Give this a try. 2 of these. Figure out the perimeter of these 2 shapes. Let's go with these 2 and the ones at the back. Okay? We're going to challenge this. Now, ready? Huh? Find the parameter of each figure. Give your answer correct to 2 decimal places. That means you can use a calculator here. And you have the first one, 2 semicircles. Okay. The mic here is with. Have you passed it already? Okay, pass it down. Okay, let's go with figures. I have 2 semicircles here for the figure. Let's go with figure out the arcs. And then you have another smaller arc. And should I add the straight lines here? Yes, because it's part of the semicircle, right? And part of the semicircle here. So I should add the whole thing up. Okay, but adding these two is easy. Let's try to find the first one here. Okay, what will be the steps for this semicircle? This arc. The green arc. Just the green arc for the big semicircle. Green arc. Big green arc. What is the working for it? Marian, you want to help out? What's the formula for this green arc here? Just this one. Yes, good. Flip the book if the answers are before you. I'm sticking to the textbook because we have the parallel questions here. What is the working step to find this big green arc? Answer, you can answer? No? Half times pi d, thank you. What is pi here? Let's just leave it as it is. Did they tell us which pi to use? No. So what pi should we use? The calculator's pi. Good. So what's d for here? What's d for here? Marian? What's the d for here? 12, thank you. Okay, tell me about the small arc then. The small green arc. Elena? Half times pi d as well. In this case, pi is the calculator's pi and d is? Sorry? 6. Okay. Is this difficult? And so, is this difficult? Does it make sense to you? Yes? I take half times pi, calculator's pi, times 12. I can bracket this whole thing up. That is the green arc. I can equal this first also, no problem. Or I can just add everything up. Plus, open bracket, half times pi times 6. Then I plus 12 plus 6. And I get the answer already. Plus this, plus 12, plus 6. Is this okay? I get 46.27 centimeters. Is that okay? Can you understand? I have the first part here. I take the green arc, half times pi then d. I take the small green arc, half times pi times 6. Put everything together, this one plus 12 plus 6 plus this one. Is this okay? Okay, let's move on to the next one. Here, the figure is made out of two identical quarter circles. Okay? Can you figure out what measurements you need to add? They are identical quarter circles. So in this case, there are two options here. Choice number 1, I find the individual arcs. What are the two individual arcs? No, what's the individual arcs? They are two quarter circles, right? Okay. If I put the two quarter circle arcs together, option 2, what do I get? The semicircle. So there are two methods to do this. If I find the small quarter circle here, what would this be? The formula? Let's go passion. Let's find the quarter circle arc here. This one that I highlighted in green. What is the formula?
Quarter times pi r.
That's all?
Quarter times 2 pi r.
Quarter times 2 pi r. In this case, r is 3.2 centimeters. And then this arc, this one is also 1/4 times 2 pi r. You realize that I could just simply add these two together. So like Kershin said, to find the green arc, I could just combine them into an entire green arc. And that would just be half times 2 pi r. Which you could simplify easily to pi r. Can, it's the same thing, right? Yes. But I will do 3.2 times 2, right? Then times half again. You realize you will get the same thing. Half times 2 times pi times r. Then from here, I will get the perimeter will be 3.2 pi plus 1, 2, 3, 4. 3.2 plus 3.2 plus 3.2 plus 3.2. 1, 2, 3, 4. That's the calculations. Does it make sense to you? I feel like some of you, your brain energy is going low. That can't happen. Because true enough, actually, there are exam papers that happen at this time of the day. Okay. We just do one question in our worksheet, and then we call it a day. Page 177. We're now at Ansel, right? And Ephraim. Oh, Jared. Okay, let's go. The parameter of semicircle and quarter circle. So we move from level, difficulty level up and down. Hopefully you can manage it and feel more confident with the questions. (177). First, we have the semicircle and the quarter circle to challenge. Starting with the semicircles on this page. To find the perimeter, I will have to use the arc plus the diameter the arc plus the diameter. Take pi as 22/7. And so, the length of the arc should be let's write on top here the formula for the circumference of a circle. What's the formula for the circumference of a circle? Pi d or 2 pi r. It's either pi d or 2 pi r. Let's go into this one again. The length of the arc of the semicircle. What is the measurement for the length of the arc? Half the circumference, so it's half times pi d plus the diameter here. Slot in the measurements. Half times 22/7 times diameter 56 plus diameter 56. Do my simplifying. 56 I can simplify by 7. What do I get? 8. 2 I can simplify with 22. 11. 11 times 8. 88. 88 plus 56. 144 centimeters. Is that okay? The next one, go on to the quarter circle. I have the length of the arc here, and I have the radius. Thank you. The arc plus the diameter can, or the radius by the radius. Okay, so I write radius by the radius because it's as seen here. But yes, Ryan is right. These two radius add up will just give me the diameter. I can just do arc plus diameter. But you need to find the correct diameter. The length of the arc formula, Giselle?
One quarter times pi times diameter.
There's no diameter here.
Yes.
Then how? What formula should I choose?
2 pi r.
So it's 1/4 times 2 pi r plus radius plus radius. In this case, I don't have the diameter, so I will do 1/4 times 2 times pi 22/7 times radius 28. Plus radius 28 plus radius 28. I can simplify the 7. Simplify this to 4. Sorry, you can't see. Oh, it's freeze, sorry. The arc plus the radius plus the radius. The arc plus the radius plus the radius. 1/4 times 2 pi r. So 1/4 times 2 times 22 over 7 times 28. Plus the radius, plus the radius. I can simplify by simplify 4 and 28, 7 and 28. Then I can simplify this as well. In the end, it will be 44 plus 28 plus 28. You see how powerful simplifying is? You know your timetable well, you manage to just cancel out everything. Then in the end, the measurements are very straightforward. Okay? And then you have your centimeters. Is this okay? 10. I would very much wish that you would try page 178 on your own. On page 107, can you finish the last question by yourself as well? Question C, please do it by yourself, give yourself a try. If you're not sure how to do, just refer to the textbook. So many examples in there. Okay? On page 178, it's the exact same thing as the previous page. But what is different now? How has the situation on this page changed? The pi. What is pi now? Thank you very much. So, I say that again. You can use the exact same steps from the previous page to solve this. Is that okay? Now, what about question 3? In question 3, pi is not stated. So which pi do I use? Thank you. The calculator pi. Can you take note of this? And so you are not taking note of this. So, on page 178, which I wish that you go home and give it a go, and if you are not sure how to do it, refer to your textbook for those examples. We talk about this page, question 2 and question 3. Exactly the same questions as the previous page, but how has the situation changed? Your friends highlight pi is not the same. You have to use pi as 3.14 here, and for this question, use pi as the calculator's pi. Do I have to say this again? Okay.